Large language models possess vast factual knowledge, but as this shifting neural network illustrates, they frequently fail when asked to follow rigid workflows. Ask an AI model to execute a precise, multi-step job, and it will often hallucinate the logic and improvise its way to the wrong answer. The permanent solution to this unreliability is an AI agent skill. A skill is simply a package of procedural knowledge handed to an agent, organized into a specific folder structure that dictates a strict, repeatable workflow. To build one, you only need 3 basic elements. You need a standard code editor, a basic familiarity with Markdown formatting, and an AI agent platform that utilizes the Open Agent Skill Standard. By adopting this strict architecture, you stop asking the model to guess what you want. Instead, you lock down the procedure, transforming a highly unpredictable probabilistic model into a reliable, consistent tool. The root of this entire folder architecture is a single file named skill.md. When your agent starts up, this Markdown document is the primary interface it reads. This mock code editor shows exactly how that document must open, with a clean block of YAML front matter defining the skill. The Open Standard imposes absolute limits here. Your name field can hold a maximum of 64 characters, and the description field below it is capped at exactly 1,024 characters. Because agents typically have dozens of skills installed at once, they can't load the full instructions for all of them into memory. They rely entirely on these short descriptions to decide which skill to trigger. If your description is vague, like generates reports, the model will likely undertrigger, skipping right past the skill when you actually need it. To fix this, you have to write a description on the pushy side. As highlighted in bright yellow on this zoomed-in view, you must explicitly define exactly what the skill does and precisely when the agent is required to use it. Once the skill actually triggers, the agent reads the body of your Markdown file. The temptation here is to ask the LLM to write these instructions for you. Doing that will yield generic platitudes like handle errors appropriately, which the model already knows and which adds 0 actual value to your workflow. The true value of the skill.md body is human domain expertise. To get this, perform your task entirely by hand one time. As you work, write down the precise reality of your specific workflow. Pay special attention to gotchas. These are the environment-specific edge cases, weird formatting rules, and localized quirks that completely defy an AI model's reasonable assumptions. Every time you have to correct the agent's work, that correction is a gotcha. By explicitly documenting these gotchas in the main skill file, you permanently resolve them. The agent reads your manual corrections before it begins, keeping it from falling into the exact same environmental traps on consecutive runs. Writing thorough instructions comes with a structural risk. If your skill body becomes too detailed, it consumes an enormous chunk of the agent's shared context window, leaving less room for user prompts and causing the model to forget prior instructions. This progress bar represents your agent's context window filling up. To prevent memory issues, the main skill.md file has a strict quantitative threshold. You should keep the primary body text under 500 lines, which equates to roughly 5,000 tokens of consumed memory. When your instructions exceed that limit, you fix it using an architectural concept called progressive disclosure. By splitting the overflowing text off into a secondary folder, the main progress bar returns to a safe green level. Inside your main skill directory, build a subfolder named References. This directory is strictly designed to house your heavy background artifacts, like extensive historical reports or thick operational runbooks. This isolated folder structure acts as a safeguard. The agent will only open and load these heavy background files precisely when a specific step in your workflow requires them, preserving your primary context window for active problem solving. Even when you keep your instructions lean and precise, a probabilistic model still operates like the shifting metallic fluid seen here. It constantly improvises its way through the steps you provided. For loose tasks, that flexibility is helpful, but workflows often contain fragile steps. If a process involves exact mathematical calculations, complex data migrations, or strict document formatting, it has to be executed identically every single time, with 0 variation or guesswork. Looking at the split screen, we solve this by replacing the messy, error-prone text prompt on the left. Instead, we create a scripts subfolder, shown on the right, which holds deterministic, hard-coded execution code like Python or Bash scripts. Back in your skill.md file, you must apply precise syntax. Do not leave the agent's action up to interpretation. Explicitly write the command, "Run this script." This prevents the model from mistakenly trying to read your executable code as background reference material. By forcing the agent to trigger a deterministic script for fragile tasks, you entirely remove its ability to guess. The model no longer does the math. It triggers a script that does the math, permanently eliminating an entire class of hallucinated logic errors. This capability brings us to a major operational risk. Because agent skills contain folders full of executable scripts, downloading a third-party skill from the internet means running untrusted, unknown software directly on your local machine. This 100-cell grid highlights the statistical severity of that threat. A recent audit scanned nearly 4,000 public skills. It revealed that 35% harbored some type of security flaw, and 13% of those contained critical vulnerabilities, including direct prompt injections and outright malware. Zooming into one of those critical cells reveals why a strict manual vetting protocol is mandatory. Before running any downloaded skill, you must audit the scripts folder and check exactly what the code reaches out to, scanning specifically for commands attempting to access your local file system or ambient API keys. The agent skills standard is open, but that offers zero guarantees about the safety of individual files. Achieving true safety in autonomous workflows requires treating every downloaded skill with the exact same suspicion you would apply to an unknown third-party software package. Look at the finalized architecture. You have a pushy YAML trigger to ensure it runs, a heavily vetted instruction body detailing the environment, a lean references folder to protect your token limits, and a hard-coded scripts directory for fragile steps. This setup embraces a very simple operational philosophy. You supply the unique domain expertise, the AI model supplies the routine typing, and the engineered scripts enforce the strict logic. Just as this blueprint assembles into a solid engine, you can convert your most error-prone AI prompt into a strictly governed, deterministic folder structure today. The agent skill standard is evolving fast as more platforms adopt it. If you've engineered your own advanced agent workflows, especially around enforcing logic or auditing script security, drop your practices in the comments below.
Thank you. Share and subscribe to Learn AI for more AI insights.